Welcome to our 3D metal finishing webinar. We're going to dive into some of the details and explore how you can get your 3D printed parts to the exact finish that you're looking for. It's great to have an expert in the field here, Justin Michaud, CEO of REM Surface Engineering. REM is a provider of equipment and services that enable you to get your parts finished exactly the way you want them. So what options are available out there, right? I know that we talk about these are real metal parts, so you can take them, you can machine them, you can heat treat them, you can do all these kind of post-processing techniques there. But as far as finishing goes, what's kind of out there and available?
So there's a lot of different things. Touching on a few, obviously, as you mentioned, you've got your as-printed state, which this is an example of that right here. And again, that's going to be fine for some applications. For parts that get sintered, you certainly have the option of doing what you guys call a green sanding, or I think the industry calls it green sanding. So you're taking the before sintered, before hardened part, and you're able to manually just remove things. That's good for maybe some burr removal, things like that, minor little flaws. And it could also bring the roughness down, but it is a manual process, so you probably wouldn't want to do it on a high volume. Hand polishing is an option. Again, not really great for high volume, but you can give you a nice bright surface. You got to be a little bit careful with it because it's also a bit of a metal smearing operation, so you might hide some things if it's an actually dynamically loaded part, but it's very effective for some things. You've got traditional abrasive, mechanical, mass finishing operations, which can take material off and can give you any range of finishes. Pluses and minuses there. Some of the things you got to think about is you're going to have if you're going for a high level finish, you're going to have a pretty defined amount of edge radiusing. You're going to attack high raise features much more than recess features, and component complexity is maybe going to be a little bit limited. Then you've got our technology, which we call the extreme ISF process.